Hello, everyone, and welcome to another episode of From the Ground Up, a University of Chicago public policy podcast produced here at the Harris School of Public Policy. Today, we have an incredible guest with us. So please join us in welcoming Mr. Peter Affioni. Peter is a co founder and the chief commercial officer for Novion Magnetics, where he oversees business development, sales, sourcing, marketing, and public relations. In this conversation with Peter, we deep dive into the work of Novion Magnetics, understand what exactly are permanent magnets, in what industries they are applied, rare earth dependence on manufacturing of permanent magnets, and we try to understand what exactly goes into recycling of rare earth minerals and what does the larger, broader industry ecosystem looks like in this respect. With me in the studio are Yoga He and Adidapo Aziz. So without taking further time away, let's just dive straight into the conversation. All right. So Peter, would you mind telling us about what Noveon Magnetics does and what is the business like and how is it different from the competitors competing in this space?
Yeah, sure. First off, thank you for having me on your podcast. I appreciate you guys giving me a voice. But yeah, Noveon is a manufacturer of neodymium iron boron magnetic material, more specifically the sintered neodymium iron boron magnetic material. This is a very high energy, very powerful permanent magnet material. It's actually the most powerful permanent magnet material that you can manufacture in the commercial market today. There are no known substitutes, no rivals with regard to its performance, and it's a really critical material for the development of our high-tech future society when we look at especially trends in electrification and also trends in renewable energy and industries that are burgeoning in those environments. And so really what set us apart from the rest of the market and allowed us to enter the market in a very competitive way was our ability to be able to leverage a decentralized supply chain to manufacture these permanent magnet materials. And so what that means is we developed novel technology that can extract an end-of-life magnet from an end-of-life application and insert that into a magnet manufacturing process without having to use any sort of traditional hydrometallurgical and pyrometallurgical processes, which are chemical intensive and energy intensive, in order to produce a new high performance magnetic material. And so really that was kind of how we were able to sort of break through into the industry. It's super important because of a lot of the geopolitical environment that exists and a lot of the intellectual property environment that exists within the industry.
Yeah, I think we read some interesting stuff on your website about how you're trying to leverage the resources in the United States to produce your products, and also how we are seeing that you are trying to capitalize on reduce the dependence on the supply chain basis based in China. So we'll get to that in a bit. But first of all, just first to give context to our listeners and also for our better understanding, because we have had, like, Christian must have shared that we have had tremendous discussions in the recent past with authors, with subject experts, where we discussed rare earth minerals and the supply chains, and we got to understand what are the applications and what are the issues in the supply chain. But what I would like you to request you to elaborate on is how do we see, or what are the applications of a permanent magnet in various industries, and what does a permanent magnetic actually do? Because I think the listeners would quite benefit from this understanding.
Yeah, definitely. I agree with that. So think of a magnet as really the heart of electrification. Think of it as like a sibling to the lithium ion battery. So wherever there is a electrical signal that translates into a mechanical motion or vice versa, in order to have that function exist, you need to have a magnet. Okay. The most visual representation of this example is a loudspeaker. You have electrical signals that's creating movement in a cone. and you wouldn't otherwise be able to achieve that movement to create the sound waves without a magnet, right? And so now apply that logic to things that are around you in everyday life, right? So just in your car, power windows, power door locks, power seats, windshield wiper motors, the starter motor. When you step into kind of like bigger systems, the hybrid electric vehicle transmission assembly and traction drive system are all driven by motors that use these permanent magnet materials. Obviously, electric vehicle is a big one. It's a very popular one in the trends of electrification today. Renewable energy, specifically wind turbines, direct drive and hybrid drive wind turbines, to all the consumer electronics you use at your house, right? Washers, dryers, air conditioners. These magnets are really everywhere. And what makes the neodymium iron boron magnet of significant importance is its ability to reduce weight, improve efficiency, and be incredibly energy dense. So in other words, there is a huge amount of power in a very, very small form factor. Okay. And so when we think about the miniaturization of technology or the improvement and the efficiency to be gained in electrical grid infrastructure, the magnet is an important part of that energy conversion in terms of efficiency, in terms of size, in terms of weight. And so the name of the game is, how powerful can I make my magnet in as small of a space as possible?
Right, right. Thank you. And like you were mentioning, there are a lot of applications for permanent magnets. So in the episodes that we discussed, EVs, electronics, renewable energy, generation equipments and materials, all of them have certain applications of permanent magnets. So I'm pretty sure that there is a lot of demand and for permanent magnets. But what intrigued us was when we were going through the website and we were trying to gather more information about the company, we we came across certain information that was published on the website, and we would love for you to elaborate on that. So for instance, we understood that Novion is pushing for lesser dependence on rare earth minerals in its products, and the company is also trying to use and form like a viable solution by using both virgin and recycled materials in the permanent magnets. And also the company is also trying to reduce its dependence on the Chinese supply chain, and is also trying to explore, I won't say better, but ways and means to reach the same results, leveraging the domestic supply chain in the US, right? So the first part so basically how we understand is rare earth minerals are an essential component of permanent magnets. So we would want to understand what is the company doing differently to ensure the reduced dependence of rare earths with respect to manufacturing permanent magnets. And what do you think the competitors are doing differently? Are they also trying to reach the same destination?
Yeah, I think there's a lot to unpack in what you just asked, So let's start with this trend and this shift with regard to supply chain resiliency, right? And so I think that there were a lot of things that happened over the course of the last, call it 15, 20 years, where from like a macroeconomic perspective, there has been a demand shift or consumer shift or industrial shift, whatever you want to call it, in terms of how we perceive our supply chains and what we need to do in order to make them more resilient against dominant positions. And we were obviously very, very keen on this with regard to oil production and OPEC in the Middle East, and a lot of the trends in renewable energies were driven by creating a dependence or independence, excuse me, from fossil fuels. And so that narrative in a lot of ways has been just shifted regionally from the Middle East to the APAC region, and more specifically to China, because China dominates rare earth production in the same way that the Middle East dominates oil production. And so I don't think that you're ever going to be able to be on pace or compete with rare earth and its rare earth industry, right? There's a lot of dollars, there's a lot of investment, there's a lot of infrastructure that's there. There's also a lot of natural resources that there. For example, heavy rare earths are only sourced from China, right? There is no other place in the world that you can get them commercially, and you need heavy rare earth elements to produce these magnets because they're critical in especially their operation at higher operating temperatures. That said, there was an International Trade Commission case back in 2011, 2012, which really addressed the intellectual property around magnet production, which was predominantly owned by the Japanese, that created a supply chain impact. And I'm not going to get into the details of that case, but consider it a fact, and that in 2012, there was an ITC case that pretty much attacked the Western markets and specifically the consumers of these magnets that were procuring NdFeB magnets or neomagnets from non-licensed producers. And so that had an impact in terms of how the industry viewed supply chain. That, of course, has been addressed in a lot of ways due to some patents expiring, but it was nonetheless a market dynamic. And then we had Section 301 tariffs that were introduced during the Trump administration, which impacted supply chain. And there was a trickle down effect associated with that, right? I mean, we had ports that were backed up. And so an ITC case, a prohibition on the export of materials, and then protectionism on the USA domestic side all factor into lead time and price and ultimately risk of domestic manufacturing capability, or just generally manufacturing capability. It doesn't necessarily have to be USA specific. It could be, any company that has a reliance on these materials. And then the straw that broke the camel's back was a pandemic era environment where supply chains became even more bottlenecked in terms of what was being pulled in. And so now there has been a shift in terms of how companies are approaching their sourcing strategies and how they're managing supply chain. And it's all about multi-sourcing strategy, and it's moving in that direction. Let's focus on regional supply chains. Can we build out regional capability or support the development of regional capability in order to somehow mitigate against the future possibility of any one of these events occurring again that can impact price, that can impact market volatility, that can impact availability of materials, lead times, and so on and so forth. And so that's the main trend, right? So the customers are driving that, and a lot of that is driven by, the macroeconomic environment that has been a result of a multitude of things that has happened within the rare earth industry. And so from a supply chain perspective, raw material perspective, you've seen companies that have mobilized mining assets and created separation technology and are getting to a path to be able to produce the materials that are needed for production. There's still a significant gap there, right? There is very, very little metallization capability outside of China, okay? Very, very little. And when you look at the supply chain, which is, mining to leaching and separation in order to get to individual oxides, and then from leaching and separation into metallization in order to get individual metals that then are used for alloy production in magnet manufacturing. There's a big mining capability that's forming outside of the United States, none of which have heavy rare earth production. There's an oxide capability that's forming outside of China. Excuse me, earlier I said outside the United States. I meant outside of China. There's a big oxide production capability that is forming outside of China, still albeit very, very early stages. And then there is very, very little metallization capability that is forming, and none that is operational. Okay, and so that's a concern. So our approach was really built on the recycling model, as you know. And so we think of it as kind of like a reverse development of the supply chain, because our recycling technology does not follow traditional methods of recycling, which includes leaching, separation, and metallization, your hydromet and your pyrometallurgical processes. We were able to service a market using an independent supply chain in order to build high-performing magnetic material, while also building out a manufacturing capability that can act as a buyer for virgin materials when that supply chain is developed, right? And so a lot of those mining and oxide and metallization companies need somebody to sell it to outside of China, or else it's just going to go back to China, right? So that's that supply chain piece, right? So like the customers are requiring it. There's a resilience component that's important. There's a risk mitigation strategy component that's important. And from our perspective, we address that in a lot of ways from a recycling perspective. Now, the recycling supply chain in itself is also very, very immature, right? There's less than 1% of these materials are recycled, from a post-consumer perspective. And our technology has really only been in the market for about 10 years, and relative to like industrial cycles, that's not a lot, right? And so there's quite a bit of work that needs to be done from a end of life supply chain management perspective in order to see the scalability that we need to see in order to mitigate against price volatility and foreign dependence on raw materials to some capacity. The other aspect of what's being done outside of just building capability outside of China, okay, is driven by technology. And we talked about one of those technology applications, and that's Novion's magnet-to-magnet recycling technology. The other is the reduction of rare earth materials within the composition of the magnet itself. Okay, and there's a significant focus on heavy rare earth materials because they're the most expensive of the rare earth materials, or some of the most expensive of the rare earth materials, and there are no known commercially operational mining projects outside of China that we can utilize within a supply chain. And so where we are in that process and what our magnet manufacturing capability consists of is a process that reduces overall heavy rare earth composition in the production of a final product. And that's whether or not we use recycled feedstock as the primary material in our production activities. So we could be using a virgin feedstock, or we could be using a recycled feedstock. And in both cases, we are reducing the overall heavy rare earth content required in our production processes. And we do that in a lot of different ways. I don't know how technical we should get on this on this call, but that's sort of the method. As far as what other competitors are doing, because I believe that was another part of your question, most commercial magnet manufacturing operations will have a recycling rebate within their cost structure that is tied to hydrometallurgical and pyrometallurgical recovery of individual elements. Okay, and so that's typically coming from slurries or from smaller form factor waste magnets that can't be processed using the Noveon magnet-to-magnet method. And that has a massive energy impact, and it has a massive impact with regard to what can actually be recovered and how you can mobilize an end-of-life market. The other method is the heavy rare earth reduction method, which is a post-production technique where additional capex and additional process has to go into a capability that has limitations with regards to what it can do to reduce overall heavy rare earth content to produce a high performance magnet. So those methods are out there, and it's part of an environment that we're very keen on understanding and tracking, obviously, because we want to understand what the state of the art is with regard to permanent magnet manufacturing.
Right. Thank you so much. I think just for the viewers, I'll just break down very, very briefly as to what we discussed. So we discussed two primary points. First of all, we were concentrating on the supply chain aspect of things and how the companies are trying to balance the supply chain. And simultaneously, we also spoke about the technological advancement, how it is facilitating the reduced dependence on rare earths for magnet integration. I think one question that this discussion puts in my mind is, do you think, when we are talking about reducing the dependence on rare earth minerals per se, in magnets, there would be some international certifications and international standards that the permanent magnet per se needs to meet, right? So is it at all linked to the composition of the magnet being prepared, or is it just linked to the operations and efficiency or the testing of the permanent magnets once it's developed? Just out of curiosity.
Yeah, no, I maybe want to unpack that a little bit more. Like, what do you mean by like international certifications? And yeah, what do you mean by that?
So for instance, let's say a permanent magnet is, let's say, bought by EV manufacturer to be integrated in the vehicle. They would be having certain checks and balances that, okay, the magnet needs to be made of ABCD components and parts, or they just look at the efficiency of the magnet's performance and then take it. In your experience, do the industry stakeholders, they concentrate more or not at all on the composition of the how the magnets are made?
Yeah, so I think the answer is it depends on the customer, right? Because different customers have different quality specifications and quality requirements. For one customer, it might be very, very important that there's traceability all the way through to where the material is sourced, where country of origin is important because it's an important part of their procurement strategy. And they want to have, a potential failure mode identified if there is an impact on a product that they've manufactured and that's been delivered. As far as a standard, there isn't a standard for magnets, right? Like there isn't like a, a standard for this is the type of magnet that goes into an automotive industry, or this is the type of magnet that goes into an aerospace and defense application. And that's just because magnets are very, very engineered. They're highly engineered in terms of what they're intended to do for a specific application. Where there are standards are in the processes for demonstrating traceability and ultimately control over quality in production. Okay, so that's where the focus is, right? And so the customers are trying to identify upper and lower specification limits across a multitude of physical criteria. It could be magnetic properties, it could be operating temperature, it could be metrological features like size and tolerance within a size scope. It could be plating thickness. There's a handful of very critical to quality characteristics that are defined based on what the customer is designing. And then what is standardized is the process in which that information is captured and measured and controlled. Okay. There have been some talks about for very specific industries like the aerospace and defense industry to standardize magnets. And I'm not a proponent of this at all. I don't think it's really feasible with regard to the possibility behind it. And that's just because of the function of motor design and what is required. You can probably very clearly identify based off of a thoughtful demand rationalization exercise what is being used in what applications. But if we want to provide flexibility in production and ultimately innovation in the use of these materials, standardizing the magnet itself as opposed to the process, I don't think is a good idea.
Right.
This is a little bit of a pivot, but I wanted to ask about the status of REM recycling. Is there any technology you're particularly excited about? What would it take to structure a business ecosystem to facilitate feasible REM recycling as related to your business?
Yeah, I think the technology I'm most excited about is our own for obvious reasons. Look, I think there's a lot of academic institutions that are doing really good research in the area. I haven't seen any technology except for our own that has been effectively commercialized. And I think that any technology, especially when I'm talking about post-consumer, there's obviously a industry of hydrometallurgical processes that are being deployed, which are very similar to mining, very similar to what the mining industry is doing with regard to solvent extraction and the separation of individual rare earths from an ore body. It's essentially that technology that's being applied to waste magnetic material. And that's been done in China for decades. And it's where a lot of the development is happening, even in North America. with some of the more recent startups that have popped up, they're all predominantly around some sort of hydrometallurgical process where chemistry and solvents are used to separate individual rare earths from a magnet. And I think that's good, and I think it has a place within the market. But what's unique about our capability, and really our capability is the only capability in the world that can effectively do this with control over final properties delivered to a customer, is that we are eliminating the need for a leaching and separation and a metallization process and an alloy formation process when we talk about extracting a end-of-life magnet from an end-of-life application. And we are instead taking that magnet and putting it directly into the magnet manufacturing process, subsequently recycling all of the elements that are part of the composition of a magnet, which exceed 15 plus elements, as opposed to just targeting the rare earth magnets. And where we had a breakthrough and why we were able to sort of scale our business was because of our ability to produce a magnet using that material that had a step up in performance. We weren't downcycling the product into a bonded magnet or into a raw material that would then have to be used in magnet manufacturing in a more energy intensive way. We were able to essentially put that directly into a magnet manufacturing process. And that has massive implications in terms of energy reduction. You know, I think our life cycle impact analysis shows about a 48% improvement compared to the life cycle inventory. If you look at the entire life cycle inventory of the supply chain, we did a separate study where we were just looking at energy consumption from mine to magnet versus our process, and we're about 90% more energy efficient. And so that translates into cost. It also translates into our ability to mobilize a domestic market. We're not capped by essentially rare earth oxide prices. Our cap is what we can sell a magnet for. And because it's an engineered and a highly value added product, there's quite a wide range of flexibility. And so we think that it will serve as sort of a critical technology in mobilizing the waste infrastructure, not only domestically, but globally in a very, very meaningful way so that we can go well beyond what our production capacity is planned for with regard to, you know, a end-of-life magnet supply chain.
Those are pretty interesting insights. Thank you so much, Peter. This brings us to the next point. I think what I'm also particularly curious about is it would be interesting for the listeners to understand what does a recycling supply chain basically looks like for you, in the sense that when you mentioned that you're also trying to leverage the recycling materials from the waste, it would be interesting to understand where are you procuring these materials from, and when we are looking at the turnaround as to when we are putting the materials through a recycling process, what is on an average, what is the recycled usable product that the company ends up generating, which is then plugged in for permanent usage?
Sure. So I'll answer your second part of your question first because it's pretty simple. This was another advantage in our technology. It's essentially a 1-for-1. We are greater than 95% efficient with regard to introducing a end-of-life magnet into our magnet-to-magnet process to produce a new magnet. And a lot of that is not necessarily yield as it relates to the process. It's more so because we are doping the material within the batch with fresh elemental additions in order to hit target magnetic properties. And those fresh elemental additions are a part of our intellectual property portfolio with regards to how we manufacture magnets. And it's those same additions that we use in the virgin magnet manufacturing process in order to reduce overall heavy rare earth content in our final magnet product if we were to use a virgin feedstock. So I'm going to answer the first part of your question a little bit carefully because there's obviously intellectual property around sort of our sourcing strategy and what we're deploying.
Sure.
But ultimately, I would think of it like this: the less than 1% recycling efficiency is not a result of a lack of collection. Okay, it is just essentially a treatment of material as a waste byproduct or as a contamination within an existing waste infrastructure, because there ultimately isn't a economic engine, in my opinion, that is mobilizing the existing waste infrastructure to extract that material. So, I think that's a very, very important consideration, and one that I believe that we can solve because we have a strong sort of spread, let's say a strong spread with regard to value that we can offer as a percentage of recovery from an end of life application. I think that's the first point that I'll make. The second point is that, you know, reverse logistics is a known sort of operating environment within industry, right? And so it's just a matter of working within a reverse logistics environment in order to collect material and then go through the process. We have a big, big hand in developing that infrastructure, right? Most of our strategic partners that are working with us on sourcing, collection, and separation are using some sort of technology transfer that we're providing to them, either in the form patented intellectual property or trade secret that we have developed as a result of our own dismantling, harvesting, demagnetizing, and material preparation techniques. So yeah, I think like we're pretty confident with what I think we could pull in from an end of life market. A lot of it needs to be tested. Say a lot of different applications need to be tested at a much larger scale than they are right now. But every program that we've run has been at commercial scale. We're talking about tonnage quantities. We have a significant stockpile currently. We are collecting and harvesting magnets now. We're very, very confident in being able to supply at least 2,000 tons of our production with end-of-life material on a per annum basis. And so, you know, I think based on what I've seen, we can get well beyond that. And that's quite significant, right? That you know, if we get into 10, 15,000 tons end of life material in North America alone, that can address close to 50% of North American demand, you know, or United States demand. I think we're roughly around 20 to 30,000 tons of sintered neo procured for the United States market alone. That's obviously growing at a very, very large rate, but I'm not going to speculate onto what those rates are.
Sure. I was very curious. So through the discussion, we were discussing as to how the industry is trying ways and means to ensure that there is reduced dependence on the supply chain that are sometimes compromised owing to certain events, and try to diversify their supply chains as well. And there is technology to foster reduced adoption of rare earths into the permanent magnet components. I think what we would also want to understand that in your understanding, in your experience, is there how does the policy and the regulatory sphere looks like in this space? Is there like an increased push for ensuring that recycling is adopted so as to reduce dependence on imports from foreign countries, especially in the United States?
Yes, I mean, I think you could see that within the EU. They just proposed legislation called the Critical Minerals Act, which would prohibit the export of any end-of-life material that has a critical material within it, specifically, in our case, an NdFeB magnet. There's obviously a lot of government grants and government funding within the United States. The Department of Defense has been very active through DPA Title III in order to help build a supply chain. You know, quite a bit of dollars have been spent, mostly by DOE and DOD. Very little has been done by EPA or Office of Waste. So most of it's on the like primary production supply chain. And that's, if I were to break it down into categories, it would be light rare earths, heavy rare earths, metallization, magnet production. And Noveon was the recipient of one of those DPA Title III awards to build that DOT. And a lot of that has been a result of a regulatory environment that specifically within DFARS regulations has prohibited the use of Chinese neo in critical defense applications. And that regulation is expected to go all the way back through to the mine by Jan 1, 2027, I want to say. So there is some regulatory effort to help, let's say, build the industry. I think that's important, and I think that we can even be a little bit more radical. I would like to see something on the waste infrastructure side to sort of mitigate how our waste infrastructure handles end of life magnets within current equipment that is processed. I think that would help. But generally speaking, I think the number one driver in change will be the development of technology, the mobilization of private capital, and the scale up of production process and equipment. At least that's how it works here in the United States, right? You need to have a good idea, you need to have real technology, and you need to have a commercialization plan that actually has economic viability, that can mobilize markets, as opposed to relying heavily on government subsidy, really. But that said, they need to work hand in hand, and we're very, very supportive and try to educate our stakeholders as much as possible with regard to what we see as a business in this industry. And so, yeah, it's super important, and it is a part of the conversation right now. Do I think it needs to be a bigger part of the conversation? Yeah, I do. I think there's a lot of good strides that are happening, and I think we're trending in the right direction. But as always, more can be done.
Yeah, Peter, you have a very interesting background, I would say. You studied finance in college, and then you went into a very hard industry. You went into recycling, right? And you're working you're working on a product that is extremely important for energy transition. And for many other young people like me who are in college, are interested in energy. We're thinking of what is our place in this industry? What can we innovate? What can we do? For you, I wonder what's your own personal story in coming into this and being so dedicated in doing something that's in fact not easy, I can imagine.
Yeah, that's a tough question to answer, because it's like there's so much that happened over the course of my journey that put me in this situation. I think if I were to boil it down, I personally didn't really have a desire to get involved in something that was kind of in an intangible space. I studied finance, and I ended up in the world of finance, and had some successes and had some failures, and I was lucky enough. And I don't think that a lot of people are in this position, because a lot of people, the entrepreneurial environment requires a specific character, and so, I was at a very, very young age, I was able to figure out what I didn't want to do, and so I was not satisfied with paper trading and not adding real demonstrable value. Value is just kind of this weird thing, I mean, should social media platforms be valued the way that they're valued? Is it worth more than a company like General Electric in terms of what they do and what they provide in terms of infrastructure and jobs and capability and really products? So it's not for me to say, but it wasn't something that it was sort of that perspective that resonated with me personally. So yeah, I would steer people, if it were my own kids or if it was my own family, I would try to prioritize things that are real and things that are tangible and things that actually have physical impact over just chasing money, so to speak. And I was able to learn that at a very, very early age, because it's always exciting to make money, and then, but it's also kind of empty in a lot of ways. And so yeah, I was lucky. I was lucky to figure that out for myself. And so recycling kind of became my calling because I love to do a lot of things that are outdoors. I love to be outside, and I have an appreciation for my environment, and I care about my environment, and I want my kids to care about the environment, and I want them to play in the dirt and be in the mountains and that sort of a thing. And so I am not a great musician, and I'm not a good artist, and so I couldn't leave my mark in that way. And so entrepreneurialism was my sort of calling and my creativity, and I just sort of focused my efforts on something that I felt like would have a impact for the things that I felt to be noble and true, right? And so that's why recycling and then magnets became just kind of a function of that journey, right? And then I fell even more in love with magnets because of what magnets meant for our society and for future, and what that ultimately meant. And then, to be part of a massive infrastructure project like Noveon is, and to have a hand, and I'm one hand of many, right? It really does take a team to build something that I think is very meaningful and very, very impactful in a lot of different ways. Was just something that I really sought for and gravitated towards.
Yeah, thank you for that. As I was saying, as a young person going to industry and not having like a technical background, and you're really interested, you're thinking, I don't have the hard experience, but I know this is a problem that needs to be solved. And I'm kind of seeing myself in you many years ago, trying to figure out how to get into this industry. And like you said, it's finding what you're really interested in, making sure you're working on something that's impactful, and, caring more about that than things that are a little more trivial. So yeah, thank you for that. Our last question is on you. We've talked a lot about this throughout the interview, but if you could, just say very shortly, looking forward in the next few years, what would be Novion's strategy? What are you looking to achieve in the next few years in this, industry, and, the problem that you're working on?
Yeah, to just be a global leader in permanent magnet manufacturing that can ultimately set an example in terms of how we can achieve circular economies.
Yeah, and we're excited to see that. You mentioned how you want to be a supplier to global companies, and talking to you at the early stage of your company is exciting, and we'll be like looking forward to what you achieve.
Yeah, thank you. Yeah, and look, the technical aspect, I can't stress that enough. To be willing to get your hands dirty and to learn is the most important thing, and then to be fortunate enough to have people around you who can mentor you and who can teach you, whether it's within your university environment or outside of your university environment, is super critical. I wouldn't be here today if I didn't have those people around me, and I still have those people around me that are a critical part of Novion's success and continued success into the future. So I can't stress that enough. But yeah, I would say, yeah, be a global leader in neodymium iron boron magnets that can lead with regard to creating circular economies. That's kind of where I see our business.
Thank you.
All right, this brings us to the end of our podcast. We really hope you enjoyed our conversation with Peter and you're taking meaningful insights from this conversation. Have an amazing day and an amazing week ahead. Take care.